So hello guys, in this video we are going to solve this problem. So in this problem it is given that let f of x be a differentiable function in -1 to infinity and f of 0 is equal to 1 such that this limit, which is t tending to x plus 1, and numerator is t square f of x plus 1 minus x plus 1 whole square f of t, and the denominator is f of t minus f of x plus 1. So this limit is equal to 1, and based on this information we have to find the value of this limit, which is limit extending to 1, and the numerator is ln f of x minus ln 2, and the denominator is this x minus 1. So this is the problem. So let's see how we can do this. So first of all, you see here, to find out this limit we need this f of x function, and this f of x function we can get based on this information, and then we can easily find out this limit. So this is the strategy. So let's see how we can find out this f of x function based on this information. So I write that limit here. So limit t tending to x plus 1, this is the numerator, this is the denominator, and this is equal to 1. Now if you put t is equal to x plus 1 in the numerator and the denominator, you can easily see that it will be coming like this: x plus 1 whole square f of x plus 1 minus x plus 1 whole square f of x plus 1, and in the denominator we have f of x plus 1 minus f of x plus 1. So you can easily see that it is 0 by 0 form, so it is undeterminate form. So what we can do, we can apply the L'Hopital rule. So to apply the L'Hopital rule, what we can do, we can differentiate the numerator and differentiate the denominator. And so here you can see that this variable is t. So variable here is t. So you have to differentiate with respect to t, not with respect to x. You have to differentiate with respect to t, because the variable here is t, not with respect to x. So you have to not differentiate with respect to x. You have to differentiate with respect to t. So let's differentiate. So if you differentiate the numerator, it will come 2t f of x plus 1 minus x plus 1 whole square f dash t. I am differentiating with respect to t, and the denominator only comes this f dash t. So so here we have this f dash t. So now what you can do, you can put t is equal to x plus 1 in the numerator and the denominator, and so let's see what it is coming. So if you put t is equal to x plus 1, it will be coming 2 times x plus 1 f of x plus 1. Here I put t is equal to x plus 1, and it is coming like x plus 1 whole square, and here it will come like f dash of x plus 1. So f dash of x plus 1 and x plus 1 whole square. And in the denominator, you see it will come like f dash of x plus 1, which you can cross multiply here with 1. So it will come like f dash of x plus 1. So now we have this equation based on that limit. So from here, what we can do, here we have this factor. So we can take this factor to the right hand side, and we can find out the value of f dash x plus 1 in terms of this f of x plus 1. So it will be coming like 2 multiplied by x plus 1 multiplied by f of x plus 1 divided by 1 plus x plus 1 whole square. So we have this. So here it is f dash of x plus 1, but we need like f dash of x and f of x in our equation. So what we can do, we can replace this x plus 1 by x everywhere. So here it will come like this thing will come like f dash of x, and in the right hand side we have 2. Instead of x plus 1 we have this x. Here we have f of x, and here we have 1 plus x square. So this is our modified equation after replacing x plus 1 by x. So now we have this. So this is a differential equation. So what we can do, you can take this f of x to the denominator here, and it will come like f dash x divided by f of x, and then you can multiply by dx both the side, and then you can integrate. Now this we have f dash x dx divided by f of x. So this you can integrate both the sides, so it will come like ln of f of x, and here we have 1 plus x square, and its differentiation is this 2x dx in the numerator. So it will become like ln of 1 plus x square plus some constant of integration. So this is the equation after integrating. So we have this equation, and now what we can do in the problem, if you see, it will be given that f of 0 is equal to 1. So we can use this information to find out the value of this constant c. So let's use this information. So if you put x is equal to 0, we know f of 0 is equal to 1. So it will be coming like ln of 1 here. And here we have ln of 0 plus 1 and plus some constant of integration. Ln 1 value is 0. Here it is also 0 plus some constant of integration. So we can find out the value of c, and it will become like c is equal to 0. So now we have this. We know c is equal to 0. So after replacing c is equal to 0, we have this equation. We can remove the ln both the side, and lastly we have this f of x is equal to x square plus 1. So this is our f of x. So now we got this f of x function. Now we can easily find out this limit which is given in the problem. This limit, you just replace f of x here by x square plus 1, and then you can easily find out this limit. So let's see that limit. So we have this limit x tending to 1 ln of f of x minus ln 2 divided by x minus 1. So you can replace f of x by x square plus 1. Now if you see, if you put x is equal to 1, it will become like ln of 1 square plus 1 minus ln 2 divided by 1 minus 1, which is 0 by 0 form, again undeterminate form. So you can apply the L'Hopital rule, and here variable is x, so differentiate with respect to x. So you have to differentiate with respect to x. So if you differentiate, this thing differentiation is 1 divided by x square plus 1, and x square plus 1 differentiation is this 2x. This differentiation is 0, this differentiation is 1, and this differentiation is 0. So we have this. Now if you put x tending to 1 means x is equal to 1, if you put, it will become like this, which is 2 by 2, which is 1. So this is the final answer of our limit, and in this way we can solve this. So hope you like the video, then we will meet in the next.